Number 22, factor f of x into linear functions given that k is a 0 of f of x, and we're told f of x equals 2x cubed minus 3x squared minus 5x plus 6, and that k equals 1. Well, just like with number 21, what we're going to do is we're going to start out using synthetic division, given that we've been given a 0 of this function. So we'll use positive 1 and perform synthetic division on f of x. We know that with synthetic division, we have to make sure that we are in descending order of powers and that we're not missing any terms. So here we go from 3 to 2 to 1 to none, our constant. So we're in good shape. We're not missing any terms, which means we can go ahead and bring our coefficients right down. So we have 2, negative 3, negative 5, and positive 6. We know we always bring this first number down no matter what it is. And so we have 1 times 2 gives us 2. If we add vertically, we have negative 3 plus 2 is negative 1. Multiply negative 1 times positive 1 gives us negative 1. Again, add vertically, we get negative 6. And 1 times negative 6 is negative 6. And when we add vertically, we get 0. All right, we expected to get a remainder of 0 because we were told that k equals 1. 1 is a 0 of the function. When you are using synthetic division with a given 0, you would expect for our remainder to be 0, and in fact it is. The reason we did this synthetic division is for the quotient that we get. All right, and recall that this is going to end up being 2x squared minus x minus 6, right? We look back at the original polynomial, in this case 2x cubed minus 3x squared minus 5x plus 6. We look at what the highest degree was. In this case it was a 3. We drop 1 and start filling in our quotient. So if we start at 3, go down to 2, well, we have x squared minus x, and then our constant. So 2x squared, minus 1x, but of course we only say minus x. We don't usually write that coefficient of 1, and then minus 6, our coefficient. And now with our quotient here, what we're going to do is factor just like we've been factoring for many years now. We can use the AC method or the scissors method, trial and error. You could even use the quadratic formula if you wanted to. I think we'll go ahead and use the AC method here. So we know that we're going to multiply the coefficient of our squared term and our constant together. So 2 times 6 gives us 12. And now we want to list all of the factors of 12. So we have 1 times 12, 2 times 6, 3 times 4. And we're looking from this list, what factors can we, with subtraction, get a negative 1? Well, we can't use 1 and 12. 2 and 6 isn't going to work. I think the only factors that will work are 3 and 4. But if we're going to be using subtraction to get to negative 1, what do the signs of the 3 and the 4 have to be? Well, I think the only way we can get to negative 1 is if we let 3 be positive and 4 be negative. 3 minus 4 is negative 1. And now that we know what factors we're going to be using, we know that with the AC method we go from 3 terms to 4 terms. So this becomes 2x squared minus 4x plus 3x minus 6. We have 4 terms now, so we're going to factor by grouping. So we'll split this polynomial down the middle. And here on the left-hand side, we can factor out, it looks like a 2x. And that'll leave over x minus 2. We'll let the addition sign come down. And then here on the right, we can pull out a 3, which leaves behind x minus 2. We know when we factor by grouping, what's inside the parentheses has to match. And it does, so we're on the right track. And we can go ahead now, pull that x minus 2 down, which means that 2x plus 3 is left over. So x minus 2, 2x plus 3 are factors. And so is, well, what is the factor that comes from positive 1 being a 0? Well, this positive 1 as a 0 comes from the factor x minus 1. Remember, x minus 1, when you set it to 0 and then use some basic algebra, that's how we get positive 1 as a 0. It came from the factor x minus 1. So we have to remember to include that as part of our factors. So here we go. Here are all of our factors: x minus 2, 2x plus 3, x minus 1. And I didn't mention this in the previous video, and I should have, but a way that you can check yourself to make sure that your factors are correct is simply to multiply these three factors together. When you do that, you should end up back here at the original f of x. So when you multiply all three of these factors together, you do indeed get the original function, and that's a way that you can test yourself. If when you multiply your factors together you do not get what you started with, then something happened in your factoring. All right, so number 22, there are our three factors: x minus 2, 2x plus 3, and x minus 1.